So hello once again. Mm, as I told you, my name is Gashuri, even email. I would like to start our training now. Uh, my professional, I'm a water and environmental engineer. My professional. I have worked with many government institutions, NGOs, in design and construction of water supply systems. I have like 10 years of experience from now, uh, and I'm an instructor in Nziza Global Training Academy. So I would like to welcome you all in this session of WaterGEMS or design water distribution network design using WaterGEMS. I would like first to know each of you so that I will be able to know who I'm dealing with, who I'm working with, the capacity or the force that I can put in so that this training goes well. This is the first things that can start our training. But before that, let us see together what will be the curriculum of this training. As you know, we will be having 5 days training, and on this day one, we're going to start with a welcome and introduction, where I will be asking everyone to be introduced, to know each other. After we will see an overview of water distribution network. In this part, we will see the component and functionality of water distribution network, the importance in urban planning and the management, and after we will look on introduction on WaterGEMS. What is WaterGEMS? How WaterGEMS will help us. In this part, we will see the software interface and the key features and tools of the software. And after, we will look together on the basic hydraulic concept. Last time, I think there is someone who asked me what the things that you can start preparing yourself on it. Here we will look together. I know all of you have that concept already. Yes? Yes. So we will look together so that we will start at the same point so that we fly together. At that point, we will see flow, pressure, head losses, pumps, and valves. And after that session, we will look on how to set up a project in WaterGEMS. Now, it will be a time to, after seeing how the interface is looking like, how the essential tools is in the WaterGEMS is looking like, we will see now how to start up the project, how to start up a project in WaterGEMS. Creating a project, managing a project, putting some data, and setup of workspace. We look how to start up with the software. Later tomorrow, we will now start network modeling and analysis. We built a network in WaterCAD. What can now introduce to you is that with WaterCAD, you will have a real world scenario in your machine. It means your site, your network that you want to construct, you have to have it in your machine. That's how modeling is. There we will see how to add pipes, nodes, junctions, pumps, tanks, all of those infrastructures that you are facing on the site. We will see how to import it or to add it. Define network component and properties, and we will be able also to add some properties on our infrastructures. You know, we have many kinds of infrastructures. We will be able to see or to put them, to make them as real, give the properties of real ones. After, we will see network connectivity and layout. how to connect all of those infrastructures together. Because if it's find that those infrastructures are not connected, your network is not well settled. Your network is not well defined. We'll see how to connect all of those infrastructures so that we create our network. We will see how to identify issues, because if the network is not well settled, if your network in the WaterGEMS in your model is not well settled, you will find errors. It will not run. It will not operate. Uh, while it will not operate, it means you didn't even do nothing. You have to find the issues. How is those issues? What is it? What the problems? And then find a way of solving all of those issues. And after solving all of those issues, you will be able to run your model, to start sizing your pipes, to start sizing your pump, your tanks, everything. Uh, After we perform hydraulic analysis, that's what I was telling you. After finding finishing with all of the issues, you will now start doing hydraulic analysis. You size your pump, size your pipes, you put demand. All of those are calculations. Now you will be able to do it. Uh, the third day, we will be now doing advanced modeling technology and how to integrate it with GIS. WaterCAD, WaterGEMS, it's a good tool. As I told you, it's a modeling that which will give you a real situation of your network. So there is a way of integrating it with GIS. So to me, when you are working with WaterCAD, most of the time you will require to add those geographical coordinates, geographical references. It's all about those references. So to me, if for example we take a point here, that point we have here is the same point that we are going to import in WaterGEMS. To me, we add X, Y, and Z from this point. WaterGEMS will be able to analyze those tools and use it. So with that options, there is a way of integrating WaterGEMS and GIS. So to me, the data from GIS can be used immediately in WaterGEMS. The layout that you may have in GIS, in water distribution system, most of the time you're dealing with maps. Yes, you're dealing with maps. So you can take those shapefiles that you are using in maps and then import them in WaterGEMS and then run your network. Without seeing it on a map only, you will be able then to run it in your WaterGEMS. See if there is a pipe it is transporting or it is supplying this amount of water, this pressure, this velocity. You will be able now to see a kind of a map, a kind of a layout in your WaterGEMS. The way it is on a map, it will be the way it will be on a WaterGEMS. So the day three we see how to integrate WaterGEMS and GIS. Do you all know something on GIS? Somehow. Okay, it's good. At least you have some knowledge. So it will help us also to go immediately. We will have 1 hour or 2 hours to be introduced on GIS, so that we will also go on the same level and then learn. After the day 4, we will see the design and optimization. I'm supposing at that stage, all of you will be able to size, to know how to do hydraulic analysis, to see the pressure, to deal with pressures, to deal with velocities, to deal with changing the pipes, all of those hydraulic analysis at day 3. I would like all of you to know those concepts. On the day 4, it will be tough. Why? Because we will now going to be designing. You are getting me? We're going to be designing. There is all of us know how to model to do hydraulic analysis, but the concept of design, if they are telling you, Grace, there is a network, you have to bring water from this water to from the mountain I saw up there, from the mountain you saw up there up to this water. You know how to design, to optimize, to size, to do a good design, to deliver a good design of the network. So at that day, we will pass through how to do some design criteria, some economic consideration. We will do upgrading. There is somewhere that you may have existing network. We see how you can upgrade your existing network, obviously, so that while you will be back in your office and someone asks you to design a network, and you design, you give a report, you will see, this is a good report of water supply design. And therefore, we try our best to go through all of those designs that you can do. Also, optimization, so that the design that you did will be complied with the cost of the money that will require to construct your network. On day 5, it will be a day of closing. It will be a day of closing where we will see, especially water quality analysis. We will pass through the common water quality parameters, factors affecting water quality, and how to model the water quality in the WaterGEMS. And after, we will be having the certificate and the closing ceremony, and the last remarks from our leaders. So, hope all of you are already prepared for this, and I assure you that it will be an interesting session with you. So,
working as a design engineer.
Design engineer.
Little bit I have a knowledge in reference designing mostly by using Excel. So I think it's a time now we're going to forget about the Excel tools.
Yes. I'm glad that we have also a design engineer. For you, you will help most of us to know the criteria that you are based on, especially here in Tanzania, in designing, so that we will at least go through it in a WaterGEMS. Yes, because you may have some criteria, that big criteria that you always consider while designing your networks. I know it's differ from here and there, depending on the country, but we are glad that we are with you. Will be helping us to understand and to know some of the criteria that you are based on. Yes, thank you. Morning.
My name is September. I work in the same department as Santiago. I also work in the design department. Should I have a bit of knowledge on Excel sheet? Not much of knowledge on Excel sheet. I did a knowledge of it, and hopefully with this software, I hope to gain much more experience on design, specifically on simulations and attaining results that are a bit different from the Excel sheet. Of course, there are some inputs we think we can add. By the end of this session, I hope to well equip myself on this software, and well does for as it is kind of new to me, never done it before. So hopefully we can start, and the session can be as helpful to me as I hope it will be. Thank you.
You're welcome.
Good morning once again. My name is Ali Mwanja. My background is on municipal industrial service engineering. Currently, I work as a wash engineer. My role is based on the designing of the water supply project, but also implementation. And my design is Excel, Internet, WaterGEMS is new, so I'm expecting this new skills that I hope will help me advance in designing generally. About GIS, I have a bit of knowledge in it, so I'm hoping also through these trainings, I'll help someone with skills that will also help to advance generally in my design work. Thank you very much.
Yes, as I told you, the times that it took you to design with a spreadsheet, I used also to design with those spreadsheet, and it will take like a month or 2 months in designing a network like 10 kilometers networks. So that time will be divided at least into not more than 5. It will depend on how the experience you will be having in using WaterGEMS, because those starting time also will be challenging to you, because WaterGEMS most of the time it have many errors. It gives you many errors. It gives you many issues that most of the time you need to think the concept of hydraulic analysis so that you will solve those issues. But once you already being familiar with it, it will going quickly with the designs. So your time now, you will be gaining more of your time in design. Yes. Next.
My name is
Design team. You are also doing design. Also using a spreadsheet.
Yeah, we use by profession. Whether it's planning and designing without me using the Excel.
I'm glad that we all at least have a knowledge with EPANET. At least we know how to size pipes, because most of the complicated things in designing with softwares with simulation is how to size the pipes. When you increase the diameter of these pipes, this one will have a low velocity, or this one will have a high pressure. To deal with those things, I'm glad that we all have that knowledge. It's your turn.
When we start off,
Mm.
we spend most of the time
Mm.
just absorb both knowledge that have
Mm.
I'm not sure with games, but a little bit knowledge about
And that choice. Okay. I think we all, there is one remaining. You are the one remaining. Hey, and you also. Yes.
Myself, guys, I'm London. I'm a water engineer from Gate, urban water supply and sanitation. My profession is a water engineer, and I've been working as a planning
Huh?
planning
Engineer. Planning and design engineer.
concerning designing. I have experience in Excel, design using Excel, and I have experience with GIS and small ideas in Ethernet.
In EPANET.
So I expect it to have more in WaterGEMS and we build up my capacity in
In water.
Good morning. My name is Anastasios Kabudumira Felician. I'm a civil engineer. I'm working with the Ashwasa, Commercial Water Supply and Sanitation Authority, and I work as acting manager for water production. I have experience in dealing with spreadsheet as my colleague, and little knowledge on EPANET and ArcGIS, not much. I expect that after this training, I will get more skills in designing using the WaterGEMS.
WaterGEMS. Thank you all. And I see all of you, the expectation is that at least when at your return, you will all be able to jump from spreadsheet to WaterGEMS. So I'm going to try my best so that your dreams comes true after this session. And what I'm asking is just to follow, softwares. You first know how you first see how people is doing things, and then after you may repeat it yourself. And when something you didn't catch, when you didn't catch something, just ask, because we are here to help each other. And other things that I'm asking is that you continue doing practices after even this after even session at your home. Evening, you just repeat what we do, so that tomorrow you will be able to continue without asking many questions or without loss. WaterGEMS require to continue working with it. If you don't work with it, you forget. That's how it is. You have to continue being familiar with it, so that you may know even more than we will learn in this training.
Yes.
So then, let's start by saying, someone still facing the issue of acceleration. So let me tell you something. Because even today we are not going to enter directly in softwares. What we will do is to see the interface, is to see the key features and tools of the software. So that one doesn't need to have your software in your machine. So after this session, we will have like 1 hour together all to see if the office can help us, everyone to install the software in its machine. So while you will already know how the interface is, how the tools, other things is, you will be able to repeat at your home what we already saw today. So tomorrow it will be a time now to run into the software, to see how to add nodes, see how to do everything. So I'm encouraging you all to be on the same table, to help each other to understand the overview of water distribution network together, so that we all at least have a common understanding of what we are going to see during this week. Is it okay?
Yes.
Yes. So those who have challenge of installing software, we are going to take time after the session so to solve all of those questions. Is it okay? Can you ask, because your question, there may be another one who has that question. Can ask loudly so that he was asking.
Western submission, we are supposed to introduce the environmental situation in this article because we are not familiar with it.
Mm.
We need to give our directions.
Yes. Can you help me with that? Where is the toilet? Where is the? Yeah.
Kutoka nje hapo.
Reception bar, mwanzoni kuna mlango. Then na washroom. Mode reception, na mlango kwa utaona. Mode reception.
Yes, by reaching the reception, see the reception is like this. You will see a door just left on your side. That's where the toilet is. Yes. I think there is the location. The toilet is the only. But I'm asking myself why there is no ladies in the training.
Alright.
There is no knowing one.
That's my way.
Okay, so the session will be a discussing session. I don't want you to be very, very concentration. We try to be relaxing so that we not get tired quickly. So the overview of water distribution network. When they say a water distribution network by you, what do you understand? Without seeing this definition which is here, I know you all read, but I'm asking when people say water distribution network, what do you understand? Let's just discuss. Don't tell me that you don't understand that. Yes, please.
I would say it's a system that transmits water from one point to another.
One point to another. Just a system that transporting water from one place to another. Anyone else have another idea? Water distribution network. When we are saying water distribution network, most of the time we are saying a complex. It's a complex system. That complex have many components with it, but all of those components are doing a job or a duty of transmitting water from the source to the end use. That's a water distribution system. By definition here, we are saying that it is a complex system designed to deliver potable water from treatment facility to consumers. When we say treatment facility, there is many ways of understanding a treatment facility. It may be a treatment plant. It may be, groundwater also. There from groundwater, there is a treatment which is happening there. But all of those components that can contribute to the treatment of water is included there. So from the treatment facility to the end consumers. The end consumers also vary. You know that most of the people are thinking that end consumers are household, not household. Even this water is an end consumers. Even an industry is an end consumers. A market is an end consumers. A church, a mosque, everything which consumes water is an end consumers. So a water distribution network is that complex. All of those infrastructures which are contributing so that water comes from the treatment to the end consumers. There are some definition also says that the complex is starting from the source, because when we say that the water is coming from treatment facilities, we are omitting the source of the water. There are some sources which are not treated, but those sources also are included in a water distribution network. But the difference here is that this is a water distribution, not a water supply. When we say the water supply, it includes also the source and the transmission line. You get? When we say water supply system, it includes also the source and the transmission network. So, what is the difference between the transmission network and a distribution network? So, the transmission network, most of the time, are those network which is coming from the source, most of the time reaching a treatment plant, and after treatment plant, there is that line which comes from a treatment plant to a main reservoir. Those are transmission network. And when you comes from main distribution or main storage reservoir, you now start distributing water. That's where this definition is coming from the treatment facility to the consumers. When we change the definition, when we change the title to water supply, now we include also the source and then the transmission. The source can be not clean. It may have an unclean water. The transmission line will transmit water from that source to the treatment plant. The water will be treated. After treating that water, we will have it to be distributed. Most of you, what is the source of your networks? When you are designing your network, what is the component, the main component of your networks? Does your water comes from river? Does your water comes from ocean? Does your water come from the borehole? Most of your network, how is it designed? Someone can help? Yes.
Different sources. For example, we have dams, we have and we have lakes.
But they also lakes. To me, there is a network which have different sources, or each network have its own sources. To me, if it's a dam, the network takes water from that dam to the treatment plant, and then treatment plant distributes water. Is that? And boreholes also. I have worked with one of the NGO who is working here in Western Africa. I don't know if you know the NGO, the organization. Is taking water from the borehole. From the boreholes. I mean, your water, it needs to be treated. It needs to be treated. It's only disinfection. Yes. That's also it's a treatment facilities. So when we say about distribution network, it starts from that disinfection system and goes to the distribution network. But by saying water supply, start from the source, from the borehole, where you fetch water. We start by designing the pump. Design the pump. After designing the pump, you design the transmission line from the borehole to the disinfection facility, and then you have a tank. You may have a big tank, which being considered like a main storage tank, and then you distribute your waters. All the systems are the same. You will see how to design all of those systems together. Not other source that you have dam. Dam most of the time are from the river. The river, you construct a dam, and then yes, you do a reservoir, and after a reservoir, you pump your water, or you supply directly. Those works, as I said, yes.
Sorry, I want to ask one question. For our case, after treatment, from the treatment plant, we pump water to the main tank. And from there, we distribute that water for other tanks. From that big tank, we call it do we call it distribution network? Because we are not supplying direct to the end consumer.
To the consumers.
Yeah, we are supplying to
Let me help you. There is some network, based on areas, there is a way of designing your network while you are doing designs. So there is, as you said, that network is from dam or
from lake.
From lake, yes.
Then we treat water.
You take water from lake, you pump you treat water to the treatment plant, and then you pump it to the main big reservoir, and from that big reservoir you do other transmission to the other secondary tanks, and then from those secondary tanks you start distributing. So your transmission is ending at those secondary tanks. So to me, while you are not yet picking water to be consumed, you're still doing transmission. Yes, still doing transmission. Most of the times, those tanks are helping you to help for filtration. So, for example, if you have many regions that you want to distribute your water. As I'm understanding that network, you have many regions to distribute water. So you want this region to be independent, this one to be also independent, and the other one to be independent. Even if you will have a big tank, but all of those regions will not have to depend only on these big tanks. You have to transmit the water to the consumer, the region's water to its own tanks. Those are secondary tanks. So you will see in our design, you may also design a network so that you will have primary network, secondary network, and tertiary networks. Most of the time, the transmission line is ending at primary network and start distributing. But other they are taking secondary to tertiary, and you start distributing water on tertiary networks. So your question was if we have a source, and then we have a treatment plant, WTP, it's a water treatment plant. Then after this one we have a main storage tank. Then from this main storage tank, you may have different scenarios. You may choose to continue your transmission, or you may also choose to start distributing water from these areas. As you may choose also to have this storage tank at the treatment plant, or locate this storage tank at the elevated areas that you may find. You may also need funding to put the treatment plant at the source. This is also accurate because when you have the treatment plant at the source, it is helping you most of the time. There is a way that the source is down or at the lower elevation. It's encouraged to put your treatment plant near the source because by supplying the dirty water, you will need the big capacity of the pump. So this will cost you much. So it's better to put this treatment plant at the source, and then you treat your water, and then you pump your clean water. But this is the place where your source is at lower elevation, depending on comparing to the location that you want to supply your water. So this main dam, most of the time, it is also encouraged to put them at the highest elevation that you may found in an area. So to me, if you want to supply water in this area, maybe you have a source here. So this source, it may not be at the tourist part. As I understand, you are using boreholes, you are using lakes, you are using rivers, yes, and dams. Most of the time, those sources you may not find it at high elevation. I don't know if I'm right. It's difficult to find a borehole at the top of the mountain. It's difficult to find a lake at the top of the mountain. Most of the time, they are at the lower elevation. So you will immediately need to put your treatment plant exactly at the same level, at the lake or at the dam, even at the borehole. If you have disinfection system, better put it at the borehole. And then you will need to see where can I locate my main dam, my main distribution dam. You may find a location where there is high elevation. High elevation maybe, and try to imagine if it's here, you put your tank, then you pump your water to this one. So this line is what we call a transmission line. Yes, it's what we call a transmission line. You may also need, if this area is divided by 4. You may also need to say, I want this area to be independent, I want this area to be independent, I want this area to be independent. Then you go in those sub areas also, you get the most elevated areas, but which will help you to get water from here to that area, because we already chose the biggest elevation. So then, went to another one, you can even dig here, went to this one, dig here, went to this one, then went to this one. All of this, why you consider this? All of these are transmission line, because they are still transmitting the treated water or the treated water to your main reservoirs, and then from there start distributing. This is now the distribution network, and from here also you can start distributing. It's also possible to distribute from this main tank, but you distribute the area which is near that tank. Start distributing. So I think we now have the overview of water distribution network. But while you are designing your network, while you are proposing the location of your infrastructures, you just have that in mind. Better to put the elevated tank where the level is higher, so that you will be able to distribute water gravitationally. And that's what I was even explaining. We have the basic component of water distribution system. We have a collection system. The collection system is that one that we call the source. The source, most of the time, is the collection system. The source, as we saw, it can be a river, it can be a lake, it can be a borehole. All the things that can produce water. It's like the source. And after the source, we have transmission works. That part which transmits water from the source to the treatment plant, to the purification plant. And then we have that part of purification, that part of treatment. That's what we call the purification works. And then we distribute our clean waters. Those are the main components. And within those main components, we find everything: tanks, chambers, pumps, everything. You see, in the treatment plant, there is pumps, there is chambers, there is tanks, there is everything. Every infrastructure can be found in those facilities in those systems. This is what I was saying, those components, and the distribution system is that part which comes from the production or from the treatment plant to the end consumers. As I said, the end consumers is not only persons. The end consumers is not only persons. Even while you're designing, most of the time, don't design for persons only. Because most of engineers are doing that here. They told you to design a network which supply water to an area, A, and then you just design for domestic use only. After that, design domestic, do your network, you put water to the villages. After a certain time, you will find a businessman comes and put your water here. After a certain time, someone will come and put a factory here. After a certain time, someone will come and put, for example, a market. While you were designing, you were sizing those pipes. If someone puts a factory here, does those persons still having water? They will not continue to have water. If someone puts a hotel here, a hotel is consuming much water than a house, and they size a small pipe to reach me, those people will start having problems of having water. So while designing, don't consider only domestic use as an end use. You also add some industries, you also add hotels, you also add everything which can need water. You try to put them into your calculation so that, and even in your prediction, if you are saying Morogoro is getting bigger, you say maybe there is 10 hotels in Morogoro. After 10 years or after 15 years, they may be multiplied by 5 or by 6, depending on the factors of the water. You just try to put those hotels and then calculate the whole systems. I think it's the way you do. Yes?
No,
No.
we are not using that. We find the existing one, and then the existing one, we project the population from the existing one.
From the existing one.
Yeah, but not the assumption that we are going maybe to have other facilities or maybe institutions of that kind. Yeah.
But you understand that it makes sense. Because if you only consider populations, and after 1 year or after 10 years, someone comes says, no, in Morogoro I want to put, for example, Azam. For us, we know that Azam is a big factory. Imagine if Azam comes in and put his factory here in Morogoro, and you are producing someone from the treatment plant, someone from the treatment facility. Your treatment is producing how much?
8,000 liter cubic per day.
8,000.
Yes. But that is a capacity.
This is the capacity, design capacity. Then the produced capacity.
Nowadays, of course, it is changing. Sometimes we exceed that quantity.
You exceed.
Yeah, sometimes.
Okay. Let's check this, because your plant, instead of lasting 10 years, to last 5 years. Okay. Let's take 8 per day. And Azam, the boss of Azam comes in and they do a plant in your areas and is needing 5 meter cubic per day. Does your population still having much water? So you don't have water. So by predicting, when you are predicting, also it's better to predict also on infrastructures, on other infrastructures. For example, hotels, for example, markets, industries. Most of the time, industries, because industries are the one who consumes much water. Find a way or in your demographic to predict also those infrastructures. Because hotels also are expanding. They are expanding.
Yeah, adding on your explanation, as you have said, we are doing. There's expanded in the other way, where when we are doing the population protection and the water demand assessment, we refer the domestic water demand, which is the base, and then according to the design manual of the Ministry of Water in Tanzania, it has a guide. It tells you there are some criteria. Take this percentage on that calculated domestic water demand, that will be institutional water demand. This percentage, there are some criteria. On the calculated domestic water demand, that will be a commercial water demand. See, there's commercial water demand, institutional water demand, and industrial water demand. It is that.
To me, all of those additional infrastructures are being based on population water demand.
Adding to that, I think most of the in a guide, it's everything that you need to consider commercial, consider population at that time. Sometimes it happens that there are other factors that may lead that you change to what you guided to the manual, to what is actually done in the ground. And that's like issues like budgeting. So you have to minimize some of the components that you need to include in your design so that you fit into that
budget.
To that budget. So there are other components in the, like water source, or the agents of that need moment when you need water at that moment, you need to supply to that population. And the pipe is not available, and the design you need to into that. For that,
so that's also as a designer. Nowadays we did it accurate that the budget will guide you on what we design, because if the budget guides you, most of African we know the budget is almost few. So if you are going to design according to the budget you have, you will face a challenge of not delivering the service that you need to deliver. So if, for example, as he said, you are designing a system for 25 years. Most of the time, you do 25 years or 15 years. And even the system you design today is not sufficient. Imagine in your 25 years. So it will be a loss scenario. So instead, the WaterGEMS will help you now to know if I'm designing a system for 25 years, I have a network. My network is like this. Within the budget I have, what part of this network will be constructed? You are getting. What part of this network can be constructed? Then you construct this network, you propose everything which is remaining, and you will still looking for funds for the remaining.
that is the technical aspect that you can advise.
Yes.
Of course, there's other issues like political.
I know.
Because you can say, I can put all in this place, not that because of the design requirement. People don't understand.
Yes, I know. Some politicians also comes in and say, no, I want water in that. I want just to say dropping in that area. Yes, it's happened also. But by designing, it's also good to think on that, because WaterCAD give you that, WaterGEMS give you that ability just to do a quick network, a big network, and see if I start today with this amount of money, that network is designed for a period of 25 years. If I'm starting with this money, how can continue myself to construct other extensions, other areas, as we will see how, if we have like an existing network, you have it already in your model, how you can upgrade it or how you can extend it with your network. And by doing extension on it, you will see the behavior. Immediately you will see the behavior, because most of the time in Africa there is a kind of a time that you have a network. The network is passing like this one, and then the government decided to construct, for example, a village here. Yes, and they said there is a network which is passing from here. So you come, you pick water from here. You just put a valve, you install everything, you do a network. By opening this valve, your water will no longer reach another place. Is it happening here? Yes. So your WaterGEMS will now help you to see if I pick water from here and bring it to this area, will my network continue to be operational? You will see that behavior in your model. And if it shows you that the water is no longer reaching this place, how your device, if you take water from here, the other part will be immediately. So you will see it immediately in your model. Or if we drink water from here and bring water to this village, water will not reach here. But if we increase that portion of 1 kilometer, because you will see sizing see the solution, finding the solution of your network, and adding 1 kilometer, we increase this pipe to, for example, it was 150 to 200. The water will continue going everywhere. So your institution will now know we pick water from here, but we increase also this part. So you will be able to do that in your WaterCAD. You see prediction that can happen when you change your network in one way. So that's the biggest advantage of the WaterCAD. In our network, I'm glad that we all know the concept, but in our network there are some small components that we used to have, like pipes. The pipes are primary conductors that transport water across the network. We have many types of pipes. I don't know what you are using here. Types of pipes. Types of pipes. Materials. You are using steel, HDPE, PVC. They are all the same. For us also, in WaterGEMS, there is a way of putting these steel pipes. There are a way of putting PVC pipes. There are a way of putting HDPE pipes. But each pipes that you are putting, you have to change the coefficients. You have also to put the coefficients. If it's PVC, you add coefficients for PVC. You add the coefficients for HDPE. You have to deal with that. WaterGEMS is software, but which have to interpret the good data that you give. If you put PVC and you add coefficients for HDPE, the design will be wrong. We all know that. So, as I said, you have transmission. You can have transmission line which move water from the treatment plant to the storage tank. Here, it comes from the title we have, the distribution. Here, the transmission is defined from the treatment plant to the storage facilities. As they say, there is a time that you can expand your treatment plant from the source to the storage tank. This will be a transmission line, and you can extend this from this one to the other one. All of those types are transmission pipes, and we have also a distribution pipes. Distribution mains which carry water to individuals, consumers. Those hotels, those restaurants, those domestic, everywhere. We can also have pumps. The pumps, most of the time, you have two types of pumps. We have those who lift water or those who boost water. The function of the pump is to increase the pressure. The pump maintains adequate pressure within the system. To maintain adequate pressure within the systems, especially in the area with high elevation or long distance line. So, in your design also, you will need to put the pump in your systems, so to lift the pressure. When you are designing your network, there is a minimum pressure that you have to maintain. Yes, most of the time at your end use, most of the time at entering the tank, there is a minimum pressure that you most of the time which is required. So you may be starting from source and you pump. Add your pump here to pump your water. You may put it in the system, but which is not encouraged. Put a pump in the system so it will pump to the end users, unless it's the last scenario that you may need. But most of the time we put the tank to lift water to other reservoir. By locating your reservoir, you are now required to see if the place you are locating your reservoir is helping to have the minimum residual pressure that is required at each end point. So by positioning, we will see later the way of positioning your infrastructures. Most of the time the pump, most of the time the tank. In the model, the way I'm picking those dots is the same way that you will be positioning your tanks, your pumps. It's only a matter of input the data that you put on that location. We will have two types of pumps. As I said, we have a booster pumps. A booster pumps is when you want to boost your network. When there is a network which is carrying water from this place to this one, and the water is not reaching the final destination. So you boost your water. That is a booster pump. There is also a lift pump. The lift pump is when you are taking water, for example, from the lake, and it lifts that water to the treatment plant or to the main reservoir. That's a lift pump. When the water is taken from the zero elevation, if I can say. There is also valves. The valves, most of the time, we have many types of valves, but most of them, they are controlling pressure, they are controlling the flow. In WaterGEMS, we most of the time we deal with flow control valve, because it's the one who is going to help you to control the flow that you are directing somewhere. So you know, when you are designing, even in the Ethernet, that valve exists. Flow control valve, the one who uses Ethernet. You know it. No one? The one who uses Ethernet, they may know the flow control valve. The flow control valve is that valve that helps you to control the flow. Meaning, you have your network. Here, the treatment plant of the gentleman is producing. You guys. See, not see. But what I was saying, you have a network which have the gentleman treatment plant is giving 8,000, and they want 4,000 to be this part, and the other 4,000 to be another part. You will not allow your water, all of your water, to go here because it's you know the water is going where the journey is easy. It goes directly to where it is easy to go. So you will control that flow just at this inlet, so that the velocity and the flow will be adequate for this pipe. So for us, we have you will let me know the criteria of you. But for us, most of the time the velocity have to go between 0.5 and 1.5. I don't know for you. It's the same? So, to me, while designing, you have to make sure that this pipe, the velocity is not going out of this range. So the flow control valve will help you to control the flow, and while you are controlling the flow, you are controlling the velocity, and you are controlling also the pressure. So we will see most of the time flow control valve and pressure reducing valves. The reservoir and storage tank, I already talked about. Most of the time it's recommended to put your reservoir or your storage tank at the high elevation. To mean while you are designing your network, you have to analyze in your GIS or at the site where you can locate your reservoir, where you can locate your storage tank. Most of the time, the storage tank, as I said, it's better to locate them at the top level of the area that you want to supply, and then you distribute your water. Here, the function does provide storage to meet the peak demand, to maintain the pressure and act as a buffer for firefighting or emergency needs. Storage reservoir, most of the time, they act as a buffer for firefighting, because those storage tank, while you are designing, you will see a kind of Excel. In WaterCAD, you don't design a tank. You get? In WaterCAD, you don't design a tank. You just simulate that the tank that you already designed. So while you are designing a tank, based on the demand, you know how to size the tank. And after sizing that tank, you put that into your systems. So this also is the help for peak demand, to meet a peak demand. That you know that all of us in the morning, people are consuming much water. If people are consuming much water in the morning, you have to size your tank so that the water in the morning, the tank will be full, the people will consume all of the water, and during those days, those times of 10, 11, the water will be filling in your tank. So that the morning at 8, there will be no tank. That's a mistake that the designers are doing. You have to design your tank so that all of the day, your tank will be having water. Without considering the peak demand, without considering the lower demand, all of the time you have to design that your network will have water. So we'll be having there is 3 types of the tank that you may have in your network. There is underground tank. There is ground tank that is located at the ground, and there is elevated tank. In WaterCAD, in WaterGEMS, you have also to precise. These precision are not based on the tabs, as I said, but it's based on the elevation that you are putting your tank. Because while you are putting the tank, while you are giving the model the tank, they ask you the base elevation. If the base elevation is lower than the ground elevation, it will mean that your tank is underground. If it's somehow higher, it means that your tank is elevated. So by putting those elevation, as I told you, WaterGEMS is dealing with those geographical references. So when you put those elevation, they ask you ground elevation to mean the elevation that you took on the ground. They ask you base elevation. They ask you initial elevation. They ask you all those elevations, kind of like 5 elevation that they will ask you. By input it, you are precising if the tank is ground, if the tank is underground, or if the tank is elevated. You get? Yes. Hydrant, we all know hydrants are used for firefighting. You have also to know if your criteria is saying for a big hotels, the firefightings have to be installed on it. These firefightings have to be at this pressure. Yes. So you design also a network for firefighting. So you put the pressure of it on that line. The WaterGEMS is giving all of those scenarios. Meters and sensors. Meters, sensors, we usually know that our networks are having those meters and sensors. Most of the time, there is a way. I don't know if you know SCADA. Yes, there is a way of putting where the SCADA is, so that when you will having problems in your network, even if you already have the layout in your network, but there is a way of seeing it in the SCADA, of monitoring the SCADA with WaterGEMS control system. Let's see now the importance of in urban planning and management. I think from the discussions that we already have, do you at least feel that there is some importance that you may face during using WaterGEMS? At least from now, from what you already understand, do you think that there will be an importance that you will be facing while you are planning for your network? I want them to be discussed.
For me, I would say that when we talk that now, when you are trying to set, I don't know, to simulate the tank, you said that you don't design the tank in WaterGEMS, but you simulate it by putting the properties that will determine whether the tank is underground, or elevated. So,
10 minutes at a time.
So I think it's one of the things that I think that need to be considered while I'll be simulating the tanking on WaterGEMS. Yes.
Yes, that's one of the importance.
Yeah.
Any others? Hey, yourself. Let's discuss. Oh yes.
Okay. There's another challenge. I think that some of us will face when you want to do extension or order network. The challenge is that the order network is not mapped, so you don't know exactly
where is it passed?
Yes. So it's hard to simulate so that you can see at what part should I new line or at what part should I replace this part. So in order to, when I make extension, what I will do the area that I increase.
Yes. That's a good question. Unfortunately, by doing extensions, at least you will be required to map the absolute network. Because, as I said, if you had a network like this, this is let's start from the storage tank. And you want just to pick water from this point. There is, unless you do a pressure test from here, and also you calculate the flow, which is coming from here, there is no other way that you can get the pressure from here and the flow, unless you do that test. So the only way of having those data is just to map this upstream, at least from the tank where water is coming, from the first tank of the upstream where water is coming. Map from there. Reach this place, and then we take critical points of other networks. When I say critical points of other networks, it is, for example, this existing one is having a tank here, yes, and let goes also another one, tank here, and this, let's say it's coming. You take critical points. You just come and pick the last point. You pick the tank here and you pick the tank here. Even if you didn't take the survey of this line, but you already have the elevation of here, the elevation of here. You just do a schematic of this code part, just a schematic on your critical point, and then you do a survey of this one, and then you continue your critical. So from your schematic, you will be able to know if water will continue reaching this area, and this area, and this area, and then have a behavior of the transmission to this point that you pick, up to the location that you want to supply water. I don't know if you get it. Somehow it will be a challenge.
So if I understand you correctly, you have to map the existing distribution network.
Upstream. You need to map upstream of the way you want to pick. You know the water is coming from this town. The water is coming from this town. It's going down, and from the branches upstream there is critical point. You also take critical point of the coordinate of critical point of those areas, so that you may do a schematic of the upstream. So from that schematic, you will have the behavior of the rest of the part, and that line that will say transmission to this point that you pick water, and then you continue designing the way you want to design. So from that, I would like to know, how do you do your survey? How do you start when you have just an idea that you want to design a network for it somewhere? How you start your project? I don't know if I asked you. There is an idea that you want to design a network from Morogoro to Dodoma. Side place that you know. You want to design a network from Morogoro to Dodoma. How do you start doing the project? If your manager asks you to go to this village and propose a network or do a distribution network from there, how do you start as an engineer?
Survey data.
In survey data, you do what? Foundation for those areas.
Also want to take the demand for people. We want to save them.
So then there is coordinate.
It's a quick coordinate.
Coordinate, demand. So the coordinate that you took which one? Just for the critical or
You're taking the coordinates for the source
for the source?
and as well as the destination.
Sorry?
The source and where the water goes.
And the water go. Just two coordinates.
And
Even the intermediate coordinate.
The determinate coordinate. Intermediate.
Intermediate.
In between. And in between is how? So, because, let me help you. It's better to have, when you want a detailed design, it's better to have at least the coordinate for the pipeline, and the coordinate of each infrastructure that you design. Yes. So within the pipeline, it's recommended to take at least 25 meters apart. So to mean if the pipeline is this one, from this down, I just take 25, I take one coordinate, 25 meter, another 5 meter, 25 meter, and when reaching this intersection, you take one. Don't know if you do the same. Yes, you continue this line, 20 meter, 25, 25, 25. Not exactly 25. You just do a range. It's a range between 50 when the area is good. When it's very flat, you can take 50. When you have you take 10. It depends, but it's my range between at least 50 and 25. So after taking those coordinates of all of the areas, we bring it together into our. You take by using GPS or DGPS or telephone.
Of course, we use a mobile application called Locus, but also some use GPS. Yeah.
Okay. All of those are giving coordinates. X, Y, what is needed is X, Y, and Z. But as a designers, those guys who do design have to have at least GGPS. Differential GPS. It's the one who have a precision. For example, if I say that the pipe will go to pass here, it gives you exactly the location of this one. That's what you do design. Or you have damming. So from there, it will help you to do what? If I'm saying that my pipe will pass through this room, through this I'm proposing my pipe to pass here to the other room. My coordinate that I'm going to put into my WaterGEMS will be such that if someone comes and put the pipe here, there will be no problem with it. But imagine if you take a coordinate with the phone, the phone doesn't have precision. Yes? We are agree or not? The phone doesn't have precision. I can take coordinate here, but by putting it in the model, it goes to the other road. So to me, my pipe will not going to pass here. It will pass to the other side. By modeling, I'm modeling things of the other side while I have to pass my pipe here. You see the convenience. So to me, by taking coordinates, you have at least to have a device which will help you to be realistic. Yes, one of them is DGPS. Another one is GPS. GPS also is have a precision of 3 meters. 3 meters also is not a bad. 3 meters is can take coordinate here while it is at this one or while it is at this one. It's also okay. But with the phone, I'm showing certain most of the time also we do. You go on the site, you find that your GPS is not charged, and you use the phone. And when you do give someone coordinates, you start wondering when he turns at the site, he puts coordinates in a machine or in another machine, he finds that the pipe is not passing here. It's passing to the other side of the road. Most of the time,
on the mobile applications, they have like are huge. It means that even the position that is shown on the GPS system, on the mobile, sometimes it can change maybe 4 meter, 5 meters, 6 meters. Still those are wrong.
Are wrong, yes.
To that extent that may set out to like 20 meters apart.
Exactly.
Exact position.
So your big institution have to buy you at least those Garmin GPS. Those Garmin GPS for example, those who do design. I'm sure it's certain it's happened to me more than 10 times. While I take coordinate for a place, I'm passing here. And next time when even there, you know that I can take coordinate and give you that coordinate. Go and see where I located my tank. And me, I located my tank here. And you, when you come to check where I located my tank, you find that it's going water here. So to me, the model that I did is giving the result for the other here, not for here. And that will cause problems. So better also to have those stuff for those devices for taking a coordinate.
I'm
What
sorry,
I was saying.
I'm sorry, a little bit to have a question. During taking coordinates, you propose to take the 25 to 50 meters.
Yes.
How if I take more than range of 50 meters, what will happen?
What will be happening? You know, the hydraulic calculation is taken from the starting point to the stopping point. So, for example, if I took 25 meters, there is a starting point. Water is going this way. There is a starting point to end point. So my hydraulic calculations for 25 meters is giving me high chance of success. And that's one for 100 meters. So I see hydraulic great line. So during this 100 meters, there may be a hill or a small hill. And as water is going this, it's losing energies. You're getting it's losing energy. So based on these calculations of 25 meters, the head losses are very minimized. Right? While you are taking 100 meters, 200 meters, the head loss with those with the greater kind of this one have a head loss which have been increased a lot. You are getting? So it's recommended to take head losses from short distance instead of taking head losses for the long distances. It's okay.
What in another way of collecting coding, what if you use this software like Google to collect the suitable for a small project?
For small project, me, I'm still emphasizing. There is devices which have been designed to take. Yes, those one are most accurate one. So Windows or Apple may develop other one, but based on the way your phone is taking satellite, is having network, is cause problem. You know, GPS is working directly with the satellite, but your phone have to have a network before, and after having a network, it's close to the satellite, and then give you the coordinates. So there is some devices which have been designed to take coordinates. If you need to have accurate designs, when I say accurate designs, it's those designs that I will design while I will be in America, for example, and give you those designs to be implemented here in Tanzania, and you implement the way you design it. You get?
Hello.
Yes.
So let's return again to our presentation. We were able to talk about the importance of urban planning and management in water distribution system. As I said, before, the importance of water distribution network in urban planning and management cannot be overstated. To me, there is many important things that comes from water distribution network. The last point was asking you what are important things that you are seeing in designing your efficiency and your good water distribution network. Those online, are you hearing me?
Yes.
Okay, good. Can you please help us to know at least the importance things that you see in urban planning and urban planning and management of water distribution system? Hello?
Yes, instructor. I can see online we have only one student, one with HP as a name. So maybe he can answer you.
So is he hearing at least? Because I'm not seeing him. Doesn't talk.
He's not reacting. I don't know. HP, can you please unmute your mic and let us know if you are hearing? Online people, the one with HP, can you please unmute your mic and let us know? Maybe he's not around. You can continue because the video is being recorded. We share them after.
Let's catch up. He will catch up. Let's continue with the physical ones.
Yes.
We were talking about the importance of water distribution system in urban planning and management. As you are not stating yours, I'm going to give you mine. So, water distribution system in urban planning and in management, urban planning and management. This will help us when we will reach the time for optimization, because during the optimization is where you will be realizing that you need to plan well and to manage your network well, so that it will cost you unnecessary money. You are getting. So you have to know now the importance of it, how it is important to think on water distribution system while you are planning and while you are managing, so that your planning goes well and your management goes well. So that's why we are asking, how do you feel, or what do you think on the importance of water distribution system? When I say water distribution system, think on the system which is well designed, which is well working, which is well operational. So what the importance of that in planning or in management of urban? So we can get in health, on public health and quality of life. The water distribution network ensured the consistent and safe delivery of potable water, which is vital for public health, hygiene, and general quality of life. So to me, that's what I was saying. When I'm saying a water distribution system now, think on that system which is well operational, well designed, and well managed. The system which is working well. That system will improve our public health and our quality of life through hygiene, health, and general qualities. So to mean by designing that water distribution system, which is efficiency, it will help us to improve also the public health and quality of life. Firefighting and emergency, by designing your system, your water distribution systems with firefighting and emergency, it will also be good for save of life, for crucial, for emergency, and you understand that by designing your system, you have to include also the firefighting. I don't know if you include those components in your designs. Yes, you include. So to me, it is also important for us to know that water distribution system, while designing, you have to consider also firefighting, water conservation and sustainability. With growing focus on sustainability, water distribution system are essential for managing and conserving water sources. Model water distribution network use data from smart meter and sensors to reduce waste, detect leak, and improve the overall efficiencies. So by designing, as we saw before, by designing a good or an efficiency network, you will be able at least to know where the wastage is being produced, where the leakage is being detected, and how to intervene quickly. So because you will be having like the whole system in your machine or in your model. So to mean for you, it will be easy to relocate where the wastage is being produced, where the leakages is being detected, everything there. So the water distribution network also will help us in adaptability to climate change. In urban areas face increasing challenge from climate change, including droughts, extreme weather, and flooding. Well-designed water distribution network helps cities to adapt by improving resilience, water supply, and pressure management system, critical in emergency and water scarce conditions. This means while you are designing your network, you will be able to see everywhere in your network. You will be able to know there is a high pressure in these areas, there is lower pressure in these areas, there is high quantities of water which is supplied in these areas. All of those scenarios, we will be able to see it. So during those emergency and during those critical times, you will know how to manage your network. So for example, if there is an earthquake and your earthquake is hitting a city, so you know these areas is having the high pressures. So better you reduce or you cross the van which is supplying water to this area, so that this earthquake will not cause many problems with your systems. Another things which will help is when you are designing. When you are designing, you will be able to deal or to play with the pressures that you have in your network. If I allow this pressure to be at these areas, it will be a challenge, will be a disadvantage, will be advantage. You play with all of those data. So another advantage that we may know is the infrastructure resilience and the asset management. When I say infrastructure resilience, let's return again to the case of our manager. If if the designer of your treatment plant have designed a plant for 8,000 meter cubic per day, and now you are producing 10,000 meter cubic per day, to mean you are not allowing your infrastructure resilience, because your treatment plant will not last as much as it was designed for. So to me, by designing that water distribution system, is what I told you before, you have to think to all criteria, all factors which may come in within the population growth, within the city growth, within everything, so that your infrastructure will will be used for what it is designed for. It's not only the treatment plant which is being affected, even the pipe, even the van, each infrastructure there is being affected for such exceeding the capacity of producing. So while designing, you have to make sure that you are designing the things which will help you to solve the problems of water scarcity which you are looking for to solve. So that's why I was telling you, try, if you are starting design a network, not just to allow water to drop in some areas, but allow people to have water in wherever the case. If it's a matter of budget, try to deal with your manager, with your superior, so that at least you already designed a network of 10 kilometers, but the budget is for 5 kilometers. Show them that how you can manage to build 5 kilometers, and then next year, if the budget comes in again, you continue, but give those people as the money that is sufficient for them. That's how you design a sufficient network. This is the only way you can design that sufficient network. Regulatory compliance and quality standard. When I say regulatory compliance and quality standard, is this means you say that you have your standard that you are using in design. If you are saying that the velocity, for example, the model, those online, I'm checking on someone. Return again. The model is. We were asking about what do you understand by talking about WaterGEMS? WaterGEMS, please. No one have another idea? Okay, let's solve it by definition. First of all, WaterGEMS is an hydraulic modeling application. It doesn't model only water distribution system. It's model everything which is based on each have hydraulic concept. It can model all of them: open channels or closed channels, fluid mechanics, everything. It can be modeled with WaterGEMS. It provides you an easy to use environment to you to confidently analyze, design, optimize your water distribution network. So to me, as I told you, with WaterGEMS, we will be able to have an easy way Hello, how are you? You're good. Yes. Sorry? What WaterGEMS? Yes. Someone is going to help you. You introduce yourself first. So it will help you to do your design, your analysis, and your optimization quickly. You will see it after, but it will help you to do all of those stuff with water distribution system as you are focused on it quickly. Then, what can WaterGEMS help me do? Now, the problem is that you are reading, but in the first things that it will help us to grow with confidence. So by designing the network with your WaterGEMS, you will be confident that the things that you are doing, there is no error. It's well designed, and not confidence of thinking like you are a king, but the confidence that the things that you do, you already see it, you are seeing it on a table, it's correct, and it is the way that it have to be. You are getting that the confidence that they are saying. So it will help us to minimize the disruption, the errors. So you remember the errors that you are made with the Excel sheets. Yes? I don't know if you made errors, but with Excel sheet, you used to make many errors. Most of the time, you take water at the point where it haven't to be taken. Yes? You are laughing. So there is many errors, and also for checking for those errors, most of the time is impossible. So with WaterGEMS, it will help us to minimize the disruption, prioritize the renewal decision. So to me, with WaterGEMS, those managers will be able to make a decision, because in any thinking that you can have, you will be able to sit on table, analyze your network quickly, and make a decision. It will help us to work with multiple platforms that I already told you, because you may be working with WaterGEMS. You produce all of your network, you produce all of your pipes, nodes, everything. But after you think, does those infrastructures located at the right place? You have to go on GIS to see. You immediately export all of your data, all your things, export it into shape files, you put it into GIS and see. If, for example, I ask this man, go on site and put on a mountain Kilimanjaro, that mountain is called what? Put on Guru the tank. He go and he put them, he give me coordinate. Just I put in the WaterGEMS, I make calculations, but after I say, did that man, did he really put that tank on the top of the Uguru mountain? I immediately go to GIS. I put all of those data into GIS and see on a map if it appear on the right place. I would like, after designing those stuff, I would like immediately to see the profiles. Do you plot the profiles also? Longitudinal profiles of the network. Immediately I would like to see the profiles. Okay, I import the data from WaterCAD, WaterGEMS, X, Y, and Z, and then give that to a man from draftman for AutoCAD to sketch. After sketching, he return again. I have to check if the way my network goes is the same as the way the one who sketched the profile did. I don't know if you do that. So I merge the map I have, the layout I have in WaterGEMS with the layout I have with AutoCAD, and also with the layout I have with GIS. So the WaterGEMS is help us to work with multiple platforms. It helps us to optimize model calibration and design and operations. This we already says the WaterCAD will help us to optimize your network. When I say optimize my network, please start to understand that by having a network, big network, my designer there, the name is Kihaka designed the network. He gave that design to manager Matumu think the network will cost 100 million. Is it a way of optimizing that network? We will start thinking, what if
I reduce this by. Okay? You have your network, you already designed it, everything, but you will start. What if I reduce this by? We'll just take this by, reduce it, and run the model. The model is running. Circular. You just take the pipe from this one to this one, you reduce to 100. You do it immediately, you put in calculation, you update the DOP. We will continue. What if I reduce this part also? You continue playing like this until your network is full optimized. You get that the big good things with WaterGEMS. Instead of saying, I already designed the network, it's already done. We will have a chance to optimize. See, what if I divide this? What if I increase this? What if I... You play with all of the network. By playing it, you see how the network is being behaved. So then, after optimization, it will help us also to forecast operating condition and potential issues. By playing with that network, you will also be able to know, for example, if the network is acting at this maximum level, at this place there may be more issues. You know, there is a network that you have, and you know that every month there must be a problem at this point. You already know. By there, you have to analyze in your network why at this point every month there is a leakage. Why? You just enter in your model, you just see calculations, you find that at this pipe there is high velocity. For example, if there is high velocity, what if I increase that portion of pipe? You see the kilometers, you see the lengths, you calculate everything you put, and you see the velocity now, instead of being 1.5, it becomes 1. And there will be no longer a question. You repair your network for all the time. So those are what WaterGEMS can help us while we are planning, while we are designing, even while the maintenance time have been reached. Hope everyone has now, except this one. I guess the problem is facing is the problem of password in the email. But after this session, I think we will try to help him to get the software. Others, I think you have. I'm passing to C. Areas in your roles. Don't open. I want all to be at the same level, not together. Yes. let's see the user interface. The user interface. There is an icon like this one, and this one is asking you if you want a quick start lesson. From here, you will get a quick lesson of WaterCAD. You just click here, there will be a downloaded PDF which have step-by-steps of the things that you can do. You will get them. They will ask you if you want to create a new hydraulic model, if you want to start a new hydraulic model, or if you want to open an existing hydraulic model. All of both scenarios, you can do it. You think you all have that icon. So let us start a new. So we are all here. Yes? Yes, please.
Still open.
It's still opening. Okay. So that I'm just begging you. Let me at the same place. Yes, please. Let me at the same place. If you are not there, just tell us that you're not there. We are going to wait for you. Continue like this because you are so many. If someone lost, boom. We will pass all the days and nights without having anything. And you are free for asking. Free for asking. I'm here to learn here and there at the post. I'm meeting Bombo. Yes. It means you track the changes to this model. It means like if you want to continue tracking the changes on the model, if you like or you don't like. You can say yes. When there is model builder which will continue to track the things that you are going to do. Thank you.
hiyo ni kuhusu quotation. Unapata unasubmit quotation. Sasa soma huko ndani kama tuna meet
You are using it right. You are using it right.
so hivi
You have to do this. You have to buy this.
hamna nini tumo kwenye hii mizala ya elimu mizala ya fedha. Tunaweza
You will talk with us.
kama tunafanya
Start here. Yes, you can be sure.
kwa nini unitrain water science hata tu ndio kufuatia tunaendelea baadaye baadaye ndio
Hope you are all here. Done? You are remaining here? Okay. Then, our interface of WaterGEMS is look like this one. Okay? This is our interface. This is the place that your network will be located, where you will draw your network, and it have tools like Word or like Excel. Here you will be having a way to save your network, a way to save as, and a way to export, to import, and a way to export your network. So the other one, you will be having layouts. Layouts, hope you all see. The layout is where it will help you to input your infrastructures. For example, if you want to add a pipe, this is my pipes that I'm adding. Unfortunately, when you add pipe, it goes with nodes, because each pipe have to have a starting point and an ending point. So by adding a pipe, you will be adding also the nodes. Okay? You see there is a node which is being added. Okay, those are nodes. At each point where the pipe is crossing, where the pipe is stopping, there must be a node. You get? Okay. So we was on layout. Layout, there is node, there is pipes, there is junctions, there is tanks, there is reservoir. They are the one that will be mostly used. There is pump. Okay. By clicking on tank, you see I'm clicking on it. Okay, I just come into my network. I can add it here. This node will be changed into tank. You get? I do this. They are asking me, would you like to move the junction G8 into type tank? I say yes. It changed immediately. Okay, you are getting? For example, if you want to put this tank, this area, if you want to put it a tank, you just go to tank, come and
click on this, it immediately change into tank. It doesn't go only on a node or on another infrastructure. You can put it even here. Okay, I just come here, I click. Would you like to split the pipe? You do yes. Immediately the tank will be appear. Okay? We are good? Okay, then you can add also a reservoir. A reservoir, what is the difference between a tank and a reservoir?
The reservoir is open structure. The water storage, the tank is closed.
It's closed. So to me, you can take a reservoir like a dam or like a source. Thank you. Each source, you can take it like a reservoir. There is some also who put a WTP, because you will not find a WTP in the model. You can put a WTP like a reservoir or like a tank, where water is coming from. So that will be the only difference with reservoir and the tank. And on reservoir, we will see. On reservoir, we have only reservoir. Let's add it here. Yes. They ask you everything. Would you like to move the junction 8 into a reservoir? Yes. So during a reservoir, you will be having only one elevation. This is one of the properties. We will see how to see it. But I'm trying to show you. We will continue learning things. Don't see me do these things. You will see how as we proceed. So, but for the tank, as I told you before, the tank they will ask you many elevations. They will ask you a base elevation, where the base of the tank is. They will ask you ground elevation is the one that you took from the field. They will ask you minimum elevation, initial elevation, maximum elevation. All of those, they are depending on the water. On the tank, they ask you all of those stuff. So for the pump also, if for example you want to add the pump, you just go on it. You can pick it here in between the pipe, or even on a node. You get? The tank is gone. So then, this was a way of showing you the layout. Okay? So you will find also analysis. And analysis, there is a tool that you have to know. The first one is compute. This is a tool. When you are doing your network, after doing it, you have first to do validation. The validation is to validate, is to confirm if your network is well set. Okay? If your network is well set, to me, you cannot validate. Your network cannot be validated. You see, they are telling you there were problems during validation. You do okay, and you see those problems which are during your systems. To me, they are telling me problems on the pump, they tell me problems on tanks, they tell me problems on nodes. You have to solve all of those problems before validating your network. When your network is validated, is where you start computing. You understand where there is a work? The first work is to validate your network. Your network will be validated well. I was saying that we need at least one reservoir. Let's put one reservoir. Yes? We are together. You can do it yourself. You can do it yourself. Have one reservoir. Let's add a node here and another here, and then try to connect this reservoir in this node. So from there, you validate your network and see. Is it validating or yes or not? Is it validating? You just do a network like this one I did, not that one. This one I did. The small one. The reservoir and the junction. It's validating. It's not validating because my there is some properties of that. Only one pipe. I was telling you, those who finished, try to delete only one pipe and try to validate. Is it validating? Just not connected. Those one who delete one pipe, does it validate? No. Doesn't validate. So to me, if in your network there is only one junction which is not connected to your network, I say junction because it's one of the feature which most of the time escape people to be connected to the network. If there is one, imagine you have 500 nodes, and 499 are connected. One is not connected. The network will not be validated. And if it's not validated, it will not do it. Now good, how to validate it first? When it's validated, it's where you start adding instrument, adding whatever. So by validation, add that file again. We saw the first feature, first tool, validation. We also have where it is. Yes? Yes. Then we are going to see compute. Add that node.
So instead, I have a question.
Yes.
In case I have a tank in between.
You have a tank in between. We will see. We are now seeing and some features, and we are only see some features and some tools only.
You will see. We will add the pump, we will add the whatever. Yes, don't worry. When? It's not validating. Why? Okay, that's what I was saying. If there is one node which is not connected to the network, your network will not be validated. Okay, I'm coming to see. So the problem this friend of us is he had his basic junction and he didn't even know that he has. And he was running and told him the model is not running. I think we all know how to validate the model. And the inconvenience that it can happen when you did it set up where your system. You may pass like 1 week doing that, doing validation only if you don't pay attention. You get? Yes. So then you compute. Anyone have compute? Has anyone compute? Yes. What did they tell you? There is calculation summary. To me, if your model is not yet validated, it will not be computed. And when you compute, this is where the summary is coming from. This is where the results are coming from. So to me, you have to validate first. After validate, you compute. After you compute, when you compute, water is going everywhere you want. In the wrong direction. It is easy in each way they want. Now you start sizing. We are together. So we get the process now. So you open your model. After opening your model, you input your infrastructure correctly. I repeat, correctly. If you do it incorrectly, it will not validate. So then you validate your network. When it's validated, you compute. When you compute, water start going here and there and there. And then when it's compute, you start sizing. You're good? Okay. You now know where to find infrastructures. Yes, nodes, pipes, junctions. How to analyze.
Analysis is where you can find hydrant. There are some tools, there are properties, there are what is called selection set. We will all see those tools. Another things that I want to show you, we already put reservoir. We have pipes, yes, and we have nodes, 2 pipes and 2 nodes. There is what is called reflex table. Reflex table, to those who use GIS, it's like attribute table. Reflex table. It's like attribute, but it's like attribute table to those who use GIS. So by clicking on reflex table, you will get a table like this one. We are all together. You just do it in your machine and see. I see. Reflex table. You will get another table. Yes? Mine is coming here because I put it here. Yours, it may come another place. Yours may come like this. Yes? So from this one, there is pipes, there is a table of fire flow, there is a table of pump, there is a table of pipe, there is a table of junction, there is a table of reservoir, and all things that you may have. There is a table of it. You can just click on it, double click on it, and it will bring you another table. Here I clicked on reservoir. It may give me a table of reservoir. Double click on it. So those tables that I give you, they are tables that shows you the properties of the infrastructures that you are clicking on. If you have one reservoir, that's why you are seeing there is one log here. Yes. If we may have like 10 reservoirs, all of those reservoirs will be listed there, and each one you will find their properties. Not only that, we will see a way of showing others, but now I'm showing you how reflex table and how to see those properties. Try to do also for the junction. You will tell me what you see. What have you seen? You saw 2, because you have 2 junctions. You have 2 junctions. So those 2 junctions, you see elevation. You see, for me, there is few elevation. There is a hydraulic grade line. There is a pressure, but you may have other things. What else? In your table.
Label.
Label. Label, I have it. Elevation, demand, thank you. Yes, pressure. Now there, when you be calculated, you will find the pressure at that node. You will saw it. The pressure at that node, the elevation of that node, the XYZ of that node. What else you are seeing? Hydraulic grade line of that node. The ID is the ID of that junction. Identification. Yes. All of those information can be found in those tables. Okay? Someone can refer to us. So someone can open also for the pipes and tell me what he's seeing. What you got?
Label, lens, start node, stop node, diameter, material.
Why is it 2 only? I have 2 pipes. Okay, we have ID, labels. What else? Length, diameter, material, darkness coefficients. Yes.
Start node and the stop node.
Start node. You remember what I told you before? Each pipe have a start node and a node. So to me, for mine, you see, this is a start node and this is a stop node, end node, or stop node. So by clicking this, it will immediately double click here on left corner. Double click on it. It will immediately show you that pipe. Okay. So by clicking on it, you will see the start node. It is R2, which is my reservoir. Yes. And the end node is junction 17, which is this one. This is where water is coming to, water is going. Yes? Okay. So then you get also the diameter. You are seeing the diameter. Yes? You are seeing the diameter. This is set by default. Yes? But here you are able to put your own diameter. Yes? We are together.
So I was asking that in the fixed table is where we set different parameters the junction, pipes, and everything.
Exactly. Yes. We are running quickly. We start the course of tomorrow. But that's good. Tomorrow you will all be familiar with what we will be doing, except this gentleman who is not yet. Yes, please.
How to change the metric system?
The
metric system.
The length.
Metric
Unit. We will see.
Because
Wait, we will see how even to set the interface. We are not yet see how to set the interface. We will see. We are just looking on the interface, how it look like, and some features that will help us to start up. Okay? You don't worry. Because you are jumping immediately, you are saying, you want to add feet. So, I think you all know about the flex table also. This is one of the features that will be mostly used. The flex table. Okay? So, the flex table can also be seen here at home. It's not necessary to go on analysis. Here at home you can find it. Okay? Another tools that I want you to know is what is.
Before we skip to another tool. Within analysis, we explain about the validation and the computation. How about the terms in the summary? What are they?
Terms?
Terms in the summary seems to be within the analysis.
The summary is the one that you see when you validate. You will see. This one, you also. When you compute, this is coming. The same, you saw? So you may want to see it when you are not validating to see. It comes the same. It's the same with the same scenarios. Yes. And the times, most of the time is the times that takes to compute the models. Yes. The simulation. When you click on it, it is coming in. Those are like results that you want to see. So the other one, tools that you want you to know is Model Builder. Model Builder. Model Builder is what is helping us to import data. Okay? It helps us to build our models instead of drawing those one. It helps us to build your models. So we will see it even after how it operate. Another things that I want you to look on is this one. There is a symbology here in view. In view, you will find a symbology. The symbology also, you will get all the infrastructures that you drawn there. There is pipe. In pipe, you may find labels, how to label your pipe. Okay. You may find junction. You can find how to label your junction or other annotation. There is color coding. We will see. But most of the time, it's color coding. Symbology is color coding and how to label your infrastructures. Yes. This is found in symbology. So to me, you saw that on my reservoir, you are finding this error too. So there is a way. You think that there is a way. If you have you think that let me remove that one. You just click here to remove. It goes, or you add. You can also think a way of changing it. Instead of labeling the label, you can also label, for example, the elevation, for example, the pressure, everything that may characterize the things that you want to symbol. Okay, you get where I found? You get? Okay. Symbology, you remember, it's here in view. You go on symbology, it comes. For example, we go on pipe, double click on it. Double click on it, there will be another item which comes. This one you can do the line width, symbol size. You can change it like here, but you can also go on label. Double click on it. This is coming. You symbol. There is length, because we remember we took on the pipe. You can label the length of that pipe. You can label the material. You can label everything which is appearing here. Those are the properties that can be shown by WaterCAD. You get? Those are the properties that can be shown by a WaterCAD on a pipe. All of those properties, if you want them, you can find them. So you can say that let's symbol the flow. You do the flow. You can position as you want, okay? And then you do apply. Our pipe, you see the flow is now symbols. We have zero flow on each pipe. Yes, we are together. This can be done even on a junction, on a tank, on each infrastructure that can be done. The symbology. We are together. Yes. Okay, symbology we saw. A property. You may also need to know the property of something. Okay? there is these icons. Okay, in these icons, in each things that I click on it, immediately its properties is coming here. Yes, for example, a reservoir in property you may find all of those things which is in the flexible will be appeared also here. But this is a quick find. So by clicking here, you will find the junction. The label is this one, X, Y, and Z is this one. The elevation is this one. Everything that can be shown by as a property, the pressure, the demand, the pressure, everything can be shown here. Yes. I want to see everyone where it is.
Anyone has a challenge on user interface?
So someone's asked me about the Unity. Yes? The problem is that we are not all together. Yeah, some are not together. So the Unity, you go to tools. So to me, when you start your software, the first things you know is to set unities. Even if we were looking for interface and tools and whatever, but let's look also on how to set the tools. You go to tools. There is a small icons here. click on it. It's an option. Okay. Sorry. Redo. Oh, repeat. You go to tool. There is a tool icons here. You click on it. This is option, specific application of the project option. You click on it. There is Unity here. Okay. So all of those Unity have to be setted before you start. So you can set before that, you can set it as a default. You set as a default as US customary or SCI as a default. SCI is the good one. Yes. It's a good one. Yes. So this can be set as a default. Okay. So, but from there, you can just pass through. The most unity that we may need is the unity of elevation, the unity of pressure, the unity of velocity, the unity of flow. You may check yourself if those unity are complying with what you want. Okay. That for elevation, there is meter that you use here for feet. Meter, good. The flow, liter per second, we are good. Head, meter, yes. Length, meter, yes. Pressure, Pascal. Flow. This one. Flow small. It's like the smallest liquid that can pass through that pipes. But most of the time we are looking for this one, the flow, which is passing the total flow which is passing through the pipes. We find also length, short length, the length, but the short length is when you are trying to see if from here to here, where is the shortest length that can be found. There is also, we found also the scaled length, but most of the time we try to look for length. The slope, meter per meter, yes. Velocity, meter per second. What I want you to change is the angle. No, the pressure. The pressure, most of the time we use the meters per this one. Meters per HO, which means it will show you at each level. For example, if you are at node X, it will show you the pressure here is at, for example, at 5 meters of water. Yes. So then you can apply yes. From there, all of your unity have been setted. Pipe diameters, it's millimeter. Pressure loss is millimeter also. Pressure loss. Diameter, only diameter. Yes. Edulous. You're asking head loss is meter. Head loss in meter. So there is another way that you can change the unity. I want you to all to follow on this. You see, we already set our unity. Yes? Density, most of the time, it depends on the liquid that you are going to use. They are putting where? What? You can put even. You can put even this one. WaterCAD. Or you rate this one. Density most of the time it doesn't. You change on depending on the liquid that you are going to model. Yes. The way that I want you to know now, by entering the property, yes, by going to the property, for example, of a junction, yes. If you go to elevation, these types of elevation, yes, and you right click on it, they will say unity and formatting. Yes, you click on it, they will give you this one, these icons. Yes, by changing this meter into feet or into kilometer, yes, let's do it into feet, for example. Okay, and do okay, it will immediately change the unity that you already set it. For example, if my elevation, I want you all to understand here. If my elevation was 1, yes, and I change this to feet, it will immediately change 1 into feet. It will calculate. Okay? To mean it's different from EPANET. You get? When EPANET you change the unity, you have to calculate also what you change into the unity. In WaterCAD, it calculates itself. When you put things in meters, it immediately calculates those things in meters. When you put it in feet, it immediately calculates those things in feet. You get? Which is different from EPANET. You say that you used to use EPANET. EPANET, for example, when you say 10 meters, and it was set in 2 meters, and the unit changed 2 feet, so you continue to equal 10. It will be 10 feet. But in WaterGEMS, when you say 10, 100, while the unity was set to 2 feet, and then your unity changed 2 meters, it will immediately change this 100 feet into meters. We are good. Yes, to mean, before inputting your data, make sure of the unity that you are working on. Yes? So after doing that, after setting your network, your wherever, your unity, we already start a new project, you can then save. Okay? You can save. By saving, they will ask you, I want you to follow, please. By saving, they will ask you where to save your document. Yes? Yes? Wherever you are starting, you can save. Okay? You get somewhere to save. Yes? You call it try one. Yes? And save. Do you all save?
Yes.
Someone doesn't yet save. All done. Those who save.
Yes.
What are they see in their saving folder? What are you seeing in your saving folder? There are some files. There are 5 files. You there are 5 files. There are also 5. There are 5. So then okay, you cross it. Close it. You close, open it again. You close and you open. Close the motion. After saving, you close. You open. Yes, open the model that you closed from the folder. Yes. Close. Yes. So, this one. Yes. Yes. So what I want to tell you is that all of those 5 files have to go straight.
Okay? It has to go together. If one is lost, your model is done. Easy. Okay? For example, there is a consultant who has to share with me the model. Just share the other files, but he removed one. You will not be able to open. To me, all of those folders, those formats have to go together. And as long as you will start continue operating on it, they will be open, they will be creating other backup files, which will continue to go together with the model. If someone asks you, share with me the model, don't just take that WaterCAD tools or icons and send him. You just take all of those folders, all of those formats together, and you share it with him. He will be able to open it. Okay? We are done. That's the last hint that I wanted to share with you before going to lunch. Okay? So you save it. You saw that there is 5 formats. That is sharing the model. You have to share all of them together. Yes, all of them together. If one is missing, the model will not be open. Okay? If you think I'm lying, try to delete one. Okay, I think we can have a lunch, and after lunch we will. After lunch, we will be having the basic hydraulic concept, also somehow concept of hydraulic designs, the flow, pressure, hydros, pump, valves operations, and for us tomorrow to start up with setting up a project in WaterGEMS. Yes. Even if I know now you can go and create a network based on what we studied. So tomorrow it will be easy for us to go now through everything. Yes? Yes. Any problems from here? Any problem? So if there is no problem up to now, we can have a break and let's meet at 2:30. 1 hour break, and at 2:30 we meet here to close the day. Okay. But as I said before, it's better to it's better if we work together with those concepts. We went together all through together, so that we may have the same common understanding on what we'll be designing tomorrow and after tomorrow, definitely. In our future experience that we're going to have in WaterGEMS. So then, there is some discussions with people that we had after the session, which I find it interesting. Someone was telling me the way, before I asked it, how do you start with your designs? There are some who give me ways, there are others who give me ways, there are others who quite it. But after the session, the morning session, some seated with me and tried to tell me, we are doing this way, we are doing this way, we are doing this way. So I don't want to go through all of your way that you are doing, but I want with you as engineers to set a way that we can start our designs, and from there we will be able to start it during the training also. So I want you to help me to set a way how we can start up our designs. For us, I was telling you that we start for preliminaries. For preliminary studies, what we call preliminaries. And then, feasibility. And after, we come to detailed design. So, done in preliminaries. In preliminaries is where your ideas are coming. You want to do a water supply system for a village. Someone can give me a name. A village.
Kiruruma.
Kiruruma. From now we are going to start Kiruruma. We have a village, Kiruruma, which needs to be supplied water. Yes? And that village is this one. The first things to do in preliminaries is to find the important information. Those information are most of the time population of Kiruruma, and after population, get all of those consumers, as I said. Hotels, there are industries, there are what else? Interesting. Institutions, public institutions, there are prisons, and don't forget prisons. There are prisons, not prisons. It's maybe. So those consumers, all consumers, we calculate their demand, and then we find the source. In preliminaries, there is demand. After demand, we find the source. So those works can be done even in the office with a desk review. Yes? You can just sit on your machine, go to your institution who provide demography issues, find the demography of that village, they give you, and then just Google, there is a river which passing there, this river has capacity of this one. You also propose a source, yes? Or you propose that there is a valley there, you can extract a borehole from there. You just analyze your area, you propose a source. After proposing the source, you may need a treatment. Obviously, we will need a treatment. If it's not a big treatment, it will be the disinfection treatment or whatever types of treatment that you may require. Yes? And after, you will see how now you are going to distribute your water. You have a demand, you have a source, you already propose a treatment methodology, and then it's now a way of finding a way of distributing your water. You will see in your area the highest point, as you said before. Yes? You go on a Google map, better to go on a Google map, or if you are having photo images for your country, do you have it? The one that you use in GIS. Orthophoto images. Orthophoto, those are photos that are by satellite that can be used everywhere in your machine without going through the internet. But they take on Google Earth, you go on Google Earth, find the highest mountain, you calculate the elevation of there, you propose where you put the tank, you propose where your distribution line will pass, yes, everything. So, taking the source here, yes, down here. Let's say we will have a tank here, yes, and then from this tank, we will have another tank here. This is a distribution tank. We will also have a junction here, another tank here, population here. You make your preliminaries in your office on a Google map. You make your preliminaries distributions, yes? And then after, you do preliminary report based on what you get. Okay? After this, you start feasibility. Before starting feasibility, for us, we now go on site. Yes? Just for preliminary site visit. You go on site, you visit the source. See, we was saying that there is a lake here. Is that really a lake? You go and see yourself as an engineer. You go to the point that you locate the tank. You see if it's really the elevated one that you can find. Yes. You just visit the main infrastructures. Good. After visiting those main infrastructures, you return to the office. Now you start feasibility. By visiting those main infrastructures, you took the location, the elevation of them. The elevation of the source, the tank, the main. You took them, and from those you start doing your feasibility. It's where now you will see if the water can come from here to here, from here to those nodes. You start your feasibility. You produce also a report, and from this feasibility you can even do it in your model. Yes. And today, I want to have a time at least to set up a kind of network like this. I want us to set up a network like this. After doing feasibility, there is a report. You find that the network can now work. And from there, now we send people to do surveys. Those surveys that you say. Those surveys in 25 meters, in 15 meters, they take all of the routes. And after taking all of the routes, they return back with the data. We take those data, we clean them. After cleaning them, put it into a model. After putting it into a model, now you start sizing a detailed design model that can be used. That's how our designs are being done. So I'm telling you that so that you can at least have a kind of agreement, or desired agreement, comprehensive of the way we are going to proceed with the design that you are going to do. So, how do you feel with that? Do you want us to add other process, to remove some process? How do you feel about it?
Sorry, can you repeat to explain the stage of detailed design?
On the detailed design then, on the detailed design, start most of the time, most of the things are coming from the model. All the things are coming from the model. Because in the model, there will be first sizing of the pipe. After sizing the pipe, you will know. You will size also the tank. When you size the tank, is where you put the real elevations of your tanks. Put the real elevations of your tanks. You put also the size of your tanks. There is a way that you see that to size the tanks. So to mean, you will get this tank, for example, at 500 meters. This is elevation. Yes. To be, for example, a tank of 15 meter cubic. So from there, a man from WaterCAD, when we going to sketch this tank, he will sketch a tank that have useful volume. Useful volume you are getting. Yes? The volume that will be used. To mean, the volume between the outlet and the overflow. The useful volume, which have 15 meter cubic, but especially which have this elevation, and then which have the inlet pipe equal to this one, and outlet pipe, 2 outlet pipe, one on this one and one on this one, depending on their DNA. You have to show in detail design, you have to show them on the sketch. If this tank has inlet of 200, for example, and has 2 outlets, one for 50, another one 110, it has to be shown in the model and on the drawing. On the drawing, not schematic like I did. In detail design, they have also to sketch the size that are matching with the dimensions. And the dimensions of the pipe have to be all the same. I will try to show you an example of a tank that has been done in detail design. Let's start with the basic of fluid mechanics. In order to size water system, it is important and necessary that the technician knows and understands how the systems works. When you say how the systems works, this is very important because as you saw in the small system that we did, the important thing is just to know how the system is working, where water is coming, the infrastructures that you have, and how you're going to model. In this course, first section is developed to functioning of gravity system, giving definition to the concepts such as gravity, pressure, head losses, and a brief description of various infrastructures and their use is also given in this section. This is because most of the people are asking if the model is dealing with some infrastructures like a valve chamber. The model will not deal with a valve chamber because the valve chamber is just an infrastructure which is helping us to take water for another direction. Most of the time it doesn't work with fluid. It's just an infrastructure to transfer water to change the direction. In the model, the only infrastructures that matter, it's the infrastructures that work with pressures, that which can cause pressures to be changed. And here when I say pressures, understand major pressures, not those minor pressures. Those pressures caused by a van, closing a van, by reducing a pipe that doesn't work in WaterCAD, unless you want to go more far. How gravity systems works? We all know that the systems is a systems which is driven by gravity. So you have to put water at your highest level so that the gravity will force water to go down and be distributed everywhere. We all know that concept, yes? Yes. But most of the time, we are facing a challenge when we are designing of putting a tank where the gravity will not allow you to reach all of the areas. For example, there is some engineers who propose just a tank, but by proposing a tank, he was supposing that the system will be governed by the gravity. He proposed just a tank here. The water was reaching all of the part of the network except the part above the tank. So to me, this line is called a static line. We will see it after. By proposing your tank or your distribution reservoir, be sure that there is no a press which is higher than your tank. Here we are not yet considering the losses which may encountered during the journey. We are just seeing the network at static level. By the pressure, the water pressure is the force which water exert on a wall of a container. It is contained. Where the container weight is contained. To mean, the pressure is that force that water is exerting on a wall. For example, if the water is filling of this room, there is a force that water is forcing on this wall. That's the pressure. Every time the water is causing also the pressure on the wall of the pipes. There is someone who asked me the density. I think it's you. The unit of meters. Here they consider 1 gram per centimeter cube. But knowing that the water that you are going to model, most of the time it have a density of 1. Let's talk about those pressures. We know that there is static pressures and dynamic pressures. Who can tell me the difference? Static pressure and dynamic pressure. I know you are reading. Okay, the static pressure is the force exerted by water on the pipe wall
when all the taps are turned off. To mean, when all the taps are turned off, there is no movement of water. To mean, there will be no losses which is being accounted also in the systems. To mean, the water is in static situations, that the pressure which is being exerted by that water is a statics. So it's where you will find here, even if water is not moving, but time by time it will reach the static level. When water is not moving, so we reach the static level. By having a tank here, when water is not moving, we will find water reaching at a straight line to that tank, the same elevation to that tank. But when water start now moving, yes, it's where the losses are start being created. The dynamic pressure is the force exerted by water on the pipe wall when one or several taps are opening, water circulated in the pipeline. So I mean, when water starts circulating from this point to the other one, there is losses which is caused by the pipe. And those losses, most of the time, they will not allow the water to reach the final destination at that static level. So we now start going down. This is dynamic line, this is static line. The difference. Here they are trying to explain what is statics and what is dynamics. The static pressure corresponds to the water column's height between the highest point of the pipe and the considered point, and is this equal to the difference of height between the highest point of the pipe and the point considered, which means when I'm taking like this is the tank, by considering it to be full, the static height will be from the level of the water to the point where I considered it to be. To mean, at this line, you may have a different static head depending on the point where you choose to be. To mean, by doing in our model, you find that there will be many nodes. So by having those nodes, each node will having its static pressure and its dynamic pressure. See, each node you may have its static pressure and its dynamic pressure. And when one falls down, to mean at that place, the water will not reach there. It's one of the notification that you will see. When you will get in the notification that there is a negative pressure in your network. The negative pressure is meaning that most of the time the dynamic pressure reached below zero. It means the water is not passing that area. That also we are able to fix our pipes. When you will be sizing your pipes, there will be a need of indicating if the pressure at certain level is a pressure which is, PN, a pipe which have PN 10, PN 16, PN 25, you know that it's when PN is 6, it means the pressure, it can reach the pressure of 16. When PN is 10, it can reach the pressure of 100, as it is described in this way. So by entering your data, you can enter a pipe, but which is not corresponding to the press that you are putting it. You are seeing the model a certain press, for example, here. For example, here it is showing you that the pressure here is 180. Yes, and then we not put a pipe for PN16. You get. So in the model, it's very easy to locate or to see, to check if the pipe that you are putting are matching with the pressure that you are putting also. So in the model, you will see, for example, you can check here, or you can even record, say that those nodes which is exceeding 100 must have a red color. Those nodes which are exceeding 160 will have a yellow color. Those nodes which is exceeding 250 will have those colors. So from there, you will be able. It will be easy for you just to localize where is needed PN16, where is needed PN6, where is needed PN10, where is needed PN200, PN25. So it will be easy. So I don't know if you guys use PN6. No, for us also we don't. Nowadays we don't even use PN10, but because of the hills there, we don't use any more PN10. Also, because most of the time there is a way of seeing the model. In the model, you saw that you are seeing like a plan view. So there is a way of sketching a profile. You will see in the model. See if you are having a plan view of these types. There is a way of sketching a profile. See the profile from here, for example, to here. You can sketch it, and from there you will be able to see where to locate your tank. And this case, I think it will not happen to you. This one, there is some people locate the pump just down the hill, and the tree stop the water to reach according to the pressures that you saw. If you locate your tank just down those hills, the water cannot go anymore this level unless you add a pump. Yes? This I already explained there. So to mean the static pressure when water start moving, you see the van here is opening. That is where the headrows are starting to be created. Even in the model, you will see when you run your model, you will see from the point A to the point B, you will be able immediately to see how losses have been changed, how losses have been created. So calculations of head losses, as I told you, most of the time, not even most of the time, the model is not dealing with those mineral losses, those losses of bend. You know, when they say that when the pipe is bending, there is some mineral losses which is created. When you cross the van, there is some minerals which is crossing, but the model most of the time doesn't deal with those small losses. Most of the time it deals with the head losses of the pipe. So one of the way of measuring head losses, we have some genius who helped us. There is Darcy, there is Hassan William, there is Mining, there is Chelsea. You will find all of those people in the model. You don't have to calculate yourself. The model itself, when you say that you will use Hassan William formula, just the model itself, it calculates it itself and give you the head losses that may occur during the running of your model. You are good? So to mean there is a way of choosing the head losses that you are going to use. And most of the time, Hazen-Williams is I think is the one that you used to use. Yes, Hazen-Williams is. In the model, you saw that they ask you a coefficient. Most of the time, we use for PVC, for HDP we use 140, and for PVC we use 130, and for iron, those font ductile iron, we use 120. So those mineral losses, I was saying there are some losses which caused by valves, there are losses which caused by T, there are losses which caused by bend, reducer, valve, and the other apparatus which may occur in the network. You will see even most of them will not be appearing in the model. But that's even why we doesn't consider most of the time those losses. I think I already talked to this positioning of our networks, how to position the tanks, how to position pumps, how to position treatment plant. We already talked about this. I don't know if it's really important to repeat it again. But for you, the exercise was this one, was just to propose, if you have a tank position, 2 tank position, here and here, to choose, just to propose where you can locate your tank, either here or either here, so that you can distribute water along this profile. Let's have some ideas. We have a profile like this one. They are giving you 2 possible locations of the site, this one and this one, and they want you to propose a good place for you to supply this region, this profile. Let's have ideas. Let's have ideas. Start from who? You.
Position number 2.
Position number 2. Number 2 is this one.
Yes.
You explain why.
Because here is supply. So my distribution line will not be covering a large distance from the supply.
Your distribution line will not covering a long distance.
Yes.
Okay. And okay,
The transmission will be long, but the distribution will be more. Of course, the consideration determines that the distribution is much larger than the transmission.
now water will reach here.
Pardon?
Our water will reach here. For example, if we have a source here,
Yes.
now water will reach here.
Where does water come from?
Yeah, we have a source here. Let's have a source here. But that's good. Any other? Let's have ideas. 22 also.
Yes, because it is slightly higher elevated.
22 is this one.
Yeah, the ground elevation is a bit high, and I suppose that if we just raise some, we put some laser, water will reach there.
Water
points.
will reach here.
Will be 12 points. Yes.
The riser will be how long? The riser of like a 15. No, elevated to 15. We elevate the tank to 15.
we must locate the intake. Where's the intake location?
Let's have others.
Sorry,
It seems you have also
I'm
another.
confused because I see the attitude. So I thought that is the highest point. No, I'm confused.
You thought this was the highest point.
No, that will be the yeah, that this side is the highest point because
This
if
one?
I see the attitude there. Is it? So from the drawing, you see the attitude of 60. There is a point of profile where the match is there. I thought that is the highest point.
Yeah. The highest point is this one. This one.
Yes.
So to me, your water have to come from here, goes here.
Yeah.
Yes. And then it comes here. That's good. The confusion things is what that we extended the attitude. You have to locate your tank where the location is high. Yes, where the location is high. Because tomorrow you will be having a profile like this one in WaterGEMS. By sketching it, you have also to know how to interpret it. Because if the attitude is here, is at 70 at this point, it means this one is 60, and this one the attitude is 10. So our tank immediately have to come here.
I'm sorry, sir. You're just explaining about the gravity, but not erasing. That is gravity.
That is gravity.
If that is the gravity, how should we place the tank at 60 height? That is the lower point from the above.
It's not even lower. We are considering the attitude. The attitude here is 70.
Yes.
You get? It's somehow. Sorry?
The drawings is
It's confusing. Yes. Yes.
Also indicated the possible tank location
At those 2 points. But this one was telling the truth because by putting the tank here, the water will be able to go down here and also to pump up to here. The easier way was this one. Yes. Let's now show you the
I'm sorry, before you proceed, why that type of graph is in that way?
is which way?
Up down.
This is because you will not see a graph, even if the graph is thrown like this one, but it is depending on two criteria. We have altitude and we have distance. So our altitude is coming from 0 to 70. So don't think that from here, going here, we are rising. No, we are going down. You get?
Formality in drawing Cartesian from 0 downwards, the x-axis and the y-axis, there is negative. That's why altitude is negative.
There is no negative. I see no negative there. There is no negative. So let's continue. So then, when you are thinking on a brake pressure tank, you already talked about a brake pressure. I think you always use it during your designs. So your brake pressure tank, you have also to position it at the press where you want just to break the pressure. So to me, may be having, let's draw it now as it has to be. You may be having the network, the source here, and they want to distribute water along this line. There are some people who come and say, I'm going to work with you because I know if I ask you to show me where to put the pressure, some will give me different locations. But there are some people who say, yeah, I'm prepared to put the pressure here. Yes? So why here? Because if I break here, the water will continue to go and they will also be able to reach this place. There are others who says, me, I prefer to let this water go, reaching there, I break here. So you, when you are designing, you just see what will be a more efficiency. If I break here, how is the pipe which will be going through this pipe? If I break here, how is the pipe? How will be the pipe to continue going with water? But I really know that by putting the tank here, this will require you high pipes, a big pipe, because they will require most energies to climb this pipe. But by breaking here, the water with the force here will be having much pressure to reach this place, and then it goes down. So you just play with those calculations. You see, in the model, it's very easy. It's just a matter of putting the tank, removing the tank, putting the tank, removing the tank. You see the scenario. Yes. In other things is that you don't have to break water where it will require you to add a pump again. Yes?
Yes.
There is someone who added a big network like this one. You find that the water is reaching this level with high pressure. And he comes to break water here. By breaking water here, it will immediately require a pump, just a small pump to reach now the tank here. So it's better also to analyze your network, your room network, and see if I put a break pressure here, what the scenario which will come at the other side. The water will continue to reach here. Instead of putting a break pressure here, what if I put here? If I want to reduce the pressure of here, you just try to analyze them in your model.
So those are already talked. The way you can put your tank and then you break the pressure. By breaking the pressure, you can fall up the residual pressure. So I think about the concept of hydraulic design. I tried to pass it through quickly so that we may jump to how to create a model, how to the next step, which is last for today. How to set up a project in WaterGEMS, creating and managing a project, importing data, and setting up the workspace. Yes? So I'm glad that we did it before. Yes? There is some that we did. So to me, up to now, if I draw a network there and ask everyone to sketch it into WaterCAD, we will be able. Yes? And the one who didn't get something, it will be now a time to check on it, and then tomorrow everyone will be okay. Yes? Yes. So about to end our day. And someone who will finish this report, someone who will not finish, please stay.